Aloha and welcome to this screencast where I'm going to go over the meteor-example-form-react sample application. The goal of this is to show you how to use the uniforms package to implement forms in Meteor. And so what do I mean by that? When you get the application up and running, you'll be presented with a screen like this that enables you to try to create a student. And what you can see here is that if I just click submit without doing anything, we get a bunch of validation errors that look pretty good. And so then if I go through and type my name correctly and my email address, and let's pretend that I am a student. I'm still a student. But I'm going to have to kind of fib about my level. My GPA, I'm going to give myself a good GPA. Date enrolled, I don't know, let's say I enrolled on this day. And I do have a hobby, paddling. And computer science is a good major for me. So I'll fill out all these forms and click submit. An alert box pops up. This is called Suite Alert, is the package I'm using, saying that the student record was collected. So I click OK, but then and you'll see that the form is now cleared, okay, back to its default values. But there's now a little dialog box at the bottom of this page that says edit this data, where this data refers to the record that was just stored in the database. And so if I click edit this data, and you can see the URL, or you'll see it better once I go to it, it's basically the host name plus student and then my email address as the kind of the unique identifier for this record. And so if I go to that particular URL, you'll see that now all of that information has been retrieved for me, and I can go ahead and say, oh, I didn't do so well last semester, and maybe, I don't know, I don't have any more hobbies, so I'll get rid of that. But I'm still a computer science major. If I click update, it says success. And just to kind of verify, in a sense, I can refresh this page, and all my changes are preserved. So that's the application. That's the entire thing right there. We have a create page, which allows you to create new objects in the system. And then we have an edit page where you get to using a URL which somehow uniquely identifies the data that you want to retrieve from the database, and then it's displayed, and you can update it. Okay, so those are the classic things. I don't have a delete. That doesn't actually usually require a form. That just usually requires a button. But for form stuff, these are the canonical cases, and you can see that we have a different controllers, text fields, text areas. We have pull down selection lists. We have a date field. We have this multi-selection list, which is kind of nice. So you can have multiple things. We have radio buttons. So I tried in this example to show you a selection of different controllers, so that you've got some code you can cut and paste for your own applications. Okay, so that's how the thing works, and we're going to spend the rest of our time basically going through the code. Okay, before I do that, I want to mention that there's this other application, Meteor Application Template React. And if you haven't gone through this application, I'd like you to kind of look at this one first before you look at Meteor Example Form, and download it and run it, because there's a lot of stuff there around the structure of the application that I'm not going to talk about in any detail here. It's gone through in more detail in this particular one. So Meteor Example Form is kind of well, frankly, I started off with Meteor Application Template React, and then I built this more complicated form example off of this. Meteor Application Template React has a super simple form. It's just got, well, let's see, what is it? It just has a little stuff, name and quantity, and a selection field. So I wanted to go into more detail on form processing, and you'll see some changes that I made, some complexities that I added to this example, so that when you are trying to build a real application, you've got a little more code you can play with and a little bit better understanding of the kind of design patterns that you need. Okay, so here we are in the actual code, and let me start off by just kind of going to the top level. What you'll see here that's important is there's a Meteor package that's unimportant, node modules unimportant, public unimportant. What is important is we're using kind of the standard application structure where there's a client, server, and imports directories. The only purpose of the client and server directories is that they both contain a main.js, which basically starts up the application by running code on the client side, in this case, and running code on the server side, in this case. And that code is by convention in the imports startup directory. So you can see here's the code that gets run on startup on the client side, and we're going to render the app component, which is the React thing that you do to display the user interface. On the server side, all we're going to do is define some publications so that the client can request data. And immediately what you can see here is that we have two collections. We have a student data collection and an enrollment data collection. And again, by convention for Meteor application structure, we have this API directory. I don't know why I think they should call it data model. I don't know why they call it API, but they do. So we're going to call it API. And within it, there's two subdirectories that each contain the definition of a Mongo collection, one called enrollment data, one called student data. And in reality, if you looked at this application, you're going to say, why did you have two collections? You could have just combined it together. And the answer is, yeah, I definitely could have. But what I wanted to do was provide an example where a form is created that combines together data from two different collections, and then when the data is edited, it has to go and update multiple collections, because that's what you normally don't really see in examples of forms. You basically see this kind of one-to-one correspondence between a form and the underlying collection or underlying table or whatever. And then when students are confronted by the need to create a form that actually pulls data from multiple sources and maybe then goes ahead and updates data at multiple sources, that feels like this incredibly complicated scenario. It's not complicated at all. So I'm just going to show you an example of how you can do that here, and then you'll see that it's not that complicated. All right, so we have these two different collections, and it's going to turn out, just to talk about the data model. The student data collection has the name of the person, their email, some biographical data, some hobbies, their level, freshman, sophomore, junior, senior, their GPA expressed as a number. So this is a number 0, 1, 2, 3, or 4, and their major, computer science, physics, whatever. Okay, and so we define this schema to constrain the values of the document, constrain the structure of the documents contained in this collection, student data, to these values. And again, this is like Meteor stuff, and you can look at Meteor application template React to get more details on that. Enrollment data just has an email which is going to identify what student we're talking about via their email. This could have been the doc ID of the student, but it's kind of cool to have a kind of a slug for to connect the two collections together. And then we have this value enrolled, which is just going to be a JavaScript date object. Okay. And as you recall, in our form, right? In our form, we have both all of that stuff from the student data collection and the stuff from this enrollment data collection. So we're basically, the form is collecting all the data that we need for both of those collections and updating both of those collections. So that's a little different from what you're used to, or what you might have seen in these simple examples. And I'm hoping that that will help you if you run into that while you're doing your own applications. Okay, so we've gone through the startup. We know about our data model now. Now let's look at the way the user interface is constructed. So remember, we got to load this app React component to get things started. And this is really straightforward. There's going to be a nav bar, which doesn't do really anything. There's going to be a footer, which also doesn't really do anything. And then in the middle, we'll have these page components, which do something. And there's only really two of them. If we're at the top level of the application, we're going to render this create student component. And if the URL is the host and then a student and then some string, which we're going to interpret as their email, we'll go to the edit student page. Okay, so those are the only two pages, and if otherwise we go to this not found page. But the only two pages in the application that have any meaning are create student and edit student. And so we can go to this pages directory where we see the create student and edit student components. So let's look at create student first. I guess I'll just kind of go through this sequentially. No, what I'm going to do actually before I talk about this is I'm going to show you what it would be like to do a form without using uniforms. Okay, so this is from Meteor Application Template React. This is the sign-in page. And I kept this around because it's kind of interesting to see how you do form processing in React without some kind of package. We use uniforms in my template. But I left this code around, and basically what you can see is you're going to render the page using, in our case, semantic UI React components to create a container, and then you create a grid inside it with some styles, and then you'll have a grid.column, you have a header, then you'll have this form component with an onSubmit handler, and then you have a segment, and you'll have an input, form input, which is of type email, and then you have an input which is of type password, and then you'll have a button that's a submit thing, and then you're going to have state. So then the thing that you'll do is you'll have this handle change method, which every time something happens inside this, it's going to update a state variable that's a state object that's internal to this component, which has the structure of which is going to build up the structure of all of the data in your form as a JavaScript object. And then when you finally get to the submit, you're going to extract out the current values of the email and password from your state variable, and you're going to do whatever you're going to do. Okay, so that's pretty simple actually to understand, but it doesn't kind of deal with the complexities of validation. It doesn't deal with the complexities of structures that could take multiple values. All of the kinds of things that if you think of schemas, you would like to be able to specify, but you can't, because in this process, people are just clicking, and you've got to somehow, build up this object. Okay, so that's one complication, and the second complication is the boilerplate of passing data in and out. Okay, which we're doing with this handle change method in this case. And it's just going to get more and more complicated when you move away from a super simple form like this, which just has two fields that are both, basically text fields. And you get into more complicated kind of controllers and more complicated kind of validation situations, and the code for this gets really complicated. So the idea of uniforms was, this guy said, look, when you're using React, there's kind of these design patterns for dealing with forms that are really common. We're going to extract all those out into a package, and we're also going to recognize that different CSS styling frameworks like Semantic UI or Bootstrap or Ant or whatever, there are these syntactic differences in the way you want to present the form or write out the form as HTML. But otherwise, pretty much everybody's doing the same thing. So we can actually provide little plugins or libraries for each of the different common CSS frameworks. And via that combination of extracting the boilerplate and providing, the syntax for the various frameworks, we can create this reusable package which makes it more simple to create forms. And so that's why I like using uniforms for this particular task. And I think also while I'm at it, what I'll do is I'll show you, here's the, the uniforms .tools homepage. It's got a little playground where you can, so you can see here are all the different forms that CSS frameworks that it supports. We use Semantic UI, so it's got one for that. It's got documentation here you can read through. It's worth reading through. And all the information is there, although sometimes, I found it a little difficult to kind of get it into my brain from the documentation, which is one of the reasons I built this template, so that you could see just a working version. The other thing that's really good for you guys to look at is this this managing forms in a Meteor-React project with the uniforms package. This is a really nice overview. It takes 6 minutes to read, apparently. And I would go through this before reading. Maybe stop the screencast right now and read through this, because it'll make what follows more understandable if you've read through his documentation. Okay, so anyway, going back to the code, here we are in the create student component. We're going to import the React stuff. We're going to import our semantic UI components. We're going to import a bunch of uniforms packages for each of our uniforms components, and you're going to see that we're importing them from the semantic UI part of the code. So it's going to generate an auto form and a text field and date field in semantic UI compatible manner, which is nice. We're going to use Sweet Alert for our alerts. One of the things we need to do with the uniforms, which is a little bit unintuitive, is we need to have this import statement here so that it loads this bridge code, even though we don't actually have to invoke that simple schema to bridge, which is why I have an ESLint disable line. So this is an import where you don't actually use this variable, but you need to have the import in order for the code to be loaded so that the bridge is there. Okay, this next piece is interesting because now we're going to import two controllers, a multi-select field and a radio field, but we're not going to do it from the uniforms package. We're going to do it from an internal, from our own internal part of the system in the forms controllers package. What I've done, and what you can do too, is you can take the code from uniforms that implement a particular controller, and you can modify it if you want to. Okay, so this is the MIT license, so you can copy the license in there. And I just wanted to show examples of this because it's not hard to do, and if uniforms isn't doing what you want to do, then you shouldn't feel afraid about just looking at the code and changing it. So for example, in the case of a radio field, what I wanted was the radio field to be in line so that all this stuff would show up on the single line versus a separate line for physics, math, chemistry, and computer science. It would just lay things out better. But the semantic UI radio component didn't have an inline option, so I copied this and I added it. Okay, in fact, this could probably become a pull request at some point. And all I really needed to do was add inline to this line here, and then check to see if the inline field was set. And if it wasn't, then I want to add this grouped thing here. So it took a little bit of finagling to figure out how to do it, but it was really, quite simple. And now I have a radio field where I can specify it as inline, and it will lay it all out on the single line. I also did this multi-select field because what I wanted to be able to do was have this nice controller here that exists in semantic UI and might not exist in some of these other layout packages, I'm not sure, but for whatever reason, it wasn't supported out of the box in uniforms. So I went ahead and created this field called multi-select field, and it basically creates this component called dropdown with multiple equals true. Those are kind of the magic words to make this. And otherwise, it's just extracted from the selectfield.js. Okay, so this is something you should definitely consider if uniforms get you close to what you need, but the layout is not quite what you want. You can fiddle with it, and it's just not that hard. Okay, so let's go back here. So we're talking about our import statements. So I got these two imports. The next thing is I'm importing some a schema and this other function from this form student form info. So I have this file here called student form info, and what it does is it specifies a schema for the form. Okay, so what what you often see in the simple examples is you have a schema for the collection and you just reuse that schema for the form, because there's this one-to-one correspondence between the collection schema for the database and what you're trying to modify in the form. But in real-world examples, eventually you don't have that one-to-one correspondence. So I just wanted to take care of that in this example so you see what happens. So in this example, in the API directory for our collection enrollment data, we have a schema right here. For our student data collection, we have a schema that's right here. And then for our form, it has its own schema, because it turns out that the schema for the form is slightly different from either of those other two schemas for the collections. And basically the way it differs is that this schema includes the enroll data. And also there's some other things, like I have this label parameter that I use, that I supply in the form schema, that Uniforms uses to provide a nice label. And some default value. There's a default value parameter that Uniforms uses. So there's some other little things that you can do, and I just wanted to make this obvious to you that when you build your own forms in your own application, you don't have to choose a schema from the collection. You can just build a schema that specifies how you want that form to be, and that's tremendously useful to Uniforms, or that's what Uniforms relies upon. It relies upon you supplying a schema that says, here are the fields in my form, and here are specifications of their underlying structure. Okay, so that's that line there. The last thing is that we import our two collections, because when we create this object, we need to update these collections. So we get these variables which are bound to the collection. All right, so then we've got this class. We do have some internal state, just a tiny little bit, and that's because when we've successfully created a form, as you recall, let me just go here. When we successfully created a form, you can see that we have this little component, or this little message box, dialog box at the bottom, that specifies where you go to edit it. And that's what this state value does. It starts off with an email thing, which is false, which is going to mean that we don't display this little message component at the bottom. But after successfully adding an object, we update the state so that email is no longer false. It's the value of the person's email, and then this message box component will actually be rendered, and it will render itself with a link to the URL where you would actually retrieve this data to edit this student. So that's what that is, and you can see actually in the edit student we don't even have a constructor. Okay, so we just need the constructor to set up that state variable. All right, the next thing is the submit form, and maybe the more sensible thing to do is look at render first. So our render form is a combination of the auto form, which is the Uniforms component, which is going to render the actual form, along with semantic UI to specify the layout, and they're kind of mixed together. You got this grid container, at the outer side, and then we get our auto form, and then in fact inside the auto form we've got some more, semantic UI stuff, and then we've got the text field, which is a component that is from Uniforms, but that basically is going to render itself as semantic UI HTML. So at the end of the day, this is all going to be semantic UI HTML. So the auto form thing, looking at it, the first thing we have this kind of a little bit opaque looking code. The idea here is that when we've successfully submitted some data in our create student thing, we want to reset the form to blank. Okay, and that involves having a reference to the form that we call reset on. And in order to get that reference to the form, we need to use this parameter to set a variable in the lexical scope of that call to be the to have the value of the reference to that form, and then we're actually going to pass it in as part of this onSubmit function that we're passing, so that once we actually are doing this submission, this is a reference to the form which we can then call reset on, which will then blank out the data. So all that stuff is just, this ref thing, and the passing into the submit is just so that we can reset the data to be nothing. It turns out in edit student, we're not going to try to reset the data to nothing. So therefore, our auto form does not have that ref thing, and we don't pass a ref into the submit, and we don't need a let of the fref and all that stuff. So it's simpler in the edit student, but in create student, since we want to blank out the form when we're done, we have to go through these shenanigans to provide the form reference object at the right point in time. So anyway, what else do we do? We pass in the schema, which is our form schema, which we've just specified here. I gave it a new name just so it didn't take up as many characters, so I didn't go over my line limit. And then on submit, we pass in a function which takes a data object which is going to be supplied by uniforms, and that's going to be an object that has the validated, or at least the schema validated data for this particular form, and we'll call our submit function with that object and the form reference. So that's why when I initially just hit submit and we got all those form validation errors, there's no code for that here. That's kind of all taken care of by uniforms, since we passed in a schema that said, here's the structure of the data, here are the allowed values, here's whether they're required or not. And we also know that this is semantic UI, so we even know how to do the validation. And in semantic UI, you can either have the validation show up below or have it show up in line, and I do this show in line error equals true every place, so that the validation errors occur right with the field, which is kind of the the groovy way to do it. Just in case you've forgotten, let me go back. Okay, so here's our create student form. I click submit, and bam, we get all these validation errors. These things are required. I needed one here. One is here, and so forth. And all that happened by virtue of the fact that I passed in a schema, and I'm using semantic UI, and I did these show inline errors equals to true. So that's really, really nice. Okay, so inside, things just kind of look like a standard. How do you lay out a form, or and how do you specify a form? You've got your text fields, you've got your text areas, you've got select fields, you've got a date field, you've got my multi-select field, you've got my radio field, you got the submit field. So basically, I think that's, okay, so then we call submit, right? So the final part of it is we call submit. It's past the validation checks, and so data is an object that we deconstruct in this line here. So we initialize a bunch of variables to have the values of these fields from the data object. So we get the name, email, bio, level, GPA, enrolled, hobbies, and major, all out of this. And then we're going to basically insert two documents, one into the student data collection and one into the enrollment data collection. And so I try to call the insert, and if it doesn't work, I'm going to bind the error to this insert error variable, and then I'm going to check to see if insert error is bound. If it is, I'm going to invoke this error message and just stop. Otherwise, if the student data.insert was successful, I'm going to call enrollment data.insert, and if that creates a problem, I'll also bind this variable and I will stop. Okay, now there is a kind of a transaction level issue here. What happens if this insert is successful and this insert is not successful? And what you really should do is you should roll back the student data insert and delete that object in the event that this fails. And I don't put that code in there, but it should be in there for production code. Okay. Otherwise, if both of these things are successful, then use an alert to say, okay, everything was successful, the record was created. I specify the state variable to be the email so that that little message thing will show up at the bottom, and I reset the form. So that's how submit works, except for one tiny little cool thing, which I also put in there just because I wanted to show you, like what happens. And what I did was in this form specification, I said that level is a string with these values. Okay, so it's, which are a range of GPAs. But just to make life interesting, I said that in the database, we're going to save GPA as just a number. And in this case, it's going to be like a number 0, 1, 2, 3, or 4. Okay? So I also wanted to illustrate the case where the way you present information in the form is not at a type level isomorphic to the way you're going to save it in the database. Because again, that's something that happens all the time, right? So the way you do it is really simple. Inside our schema, so in my database, I specify the data, the GPA data one way. I specify it as a number. In my form, I specify it another way as a string. And then I provide some functions which allow me to map back and forth between these two ways. And in this case, it's like pretty trivial what the mapping is. But in your application, it could be complicated, but that's not the point. The point is you figure out a way to go back and forth between what you want to store in the database and what you want to present to the user, and you just implement that functionality. And so where that shows up in Create Student is that when I do the insert, I take the value of GPA that's returned from my form, and I invoke this function on it to transmogrify it into the data that is actually appropriate to be saved in the database, which in this case is a number 0, 1, 2, 3, or 4. Okay, so that's the submit form for Create Student. The only last thing that we need to talk about is the Edit Student form, and here pretty much everything is the same. The difference is that when we do the Edit Student form, we have to actually retrieve that student's data from the database in order to display it in the form, because we want to fill out the form with the data for the student and allow the user to modify that data to be something different. So in order to do that, we use the standard meteor with tracker higher order function to wrap our edit student component and return a new component where we've got some reactivity. And the reactivity in this case is that first we're going to extract from the parameters of the URL the email field, and that was specified right here. Okay, we say the path to this is student, and then this colon means that this is actually a variable which is going to be bound to whatever string comes after the /student/, okay, which would be like johnson@hawaii.edu. So that's where we get the email address, and then we subscribe to both of these collections, and what we want to actually pass into our component as properties is the student document associated with whoever it is that whose page we're looking at, and the enrollment document associated with whoever's page we're looking at. Okay, and then because these subscriptions may take some time to complete, all right, we have this ready variable which checks to see if this meteor function ready returns true for both of these particular subscription objects. And our render page actually checks and will either render the page if everything's ready, which is this function here, or we'll show a little loader icon, okay, saying we're not ready yet. All right, so that's the classic. That's the way we're going to retrieve the data associated with our student, is via subscriptions, getting the document, and not actually trying to render things until we've succeeded. Okay, so what does the render look like? The render looks very much the same. We got to create this model. which is a document that contains all the data that is needed to fill out the fields in this form. And it turns out we can use this underscore function that takes an empty object, populates it with all the fields from student doc, populates all the fields from the enrollment doc, which is actually going to give us all of the fields we need for this form, with one problem, and that is that remember that GPA is stored in student doc as a number. We actually need it to be a string, so we're going to update model.gpa, replace that with the string corresponding to whatever the number was that was stored in the collection. Once we've done that, we basically have a new call to autoform. Schema is the same as before. OnSubmit is actually a little simpler than before because we don't have to deal with that form reference stuff. And we pass this thing called model, which tells uniforms how do you populate the fields in this thing with its values. And then if you look at this, you see, you know, it's all just the same. Okay. So then we call submit, and in this case, we have to find out what the ID, the doc ID of the student doc and enrollment doc are, so that we can call update with those doc IDs. And then we have a set for the particular fields. Again, we got to move that potentially new GPA value back into its string or its numeric form for update in the database. But otherwise, this just looks the same as the other one was. So there you have it. That's hopefully some useful code and gives you an understanding for how you integrate together Meteor, uniforms, semantic UI to extract or get data from the database, update it, or add new data to the database. Any questions, let me know, and have a good day.